This is Euclid Book 11, proposition number 9. Now the first thing I need to illustrate in this particular video is parallel planes. Now you see these two pieces of paper right here? Okay, I'm going to pull this up. You see how one is kind of floating above the other? Okay, that's parallel planes. This is one parallel plane, this is the other. Okay. Now, these two lines right here, this one right here, and this one right here, are in one plane. Okay? They are parallel lines, but they're both in the same plane. This line here is underneath. It's in a plane underneath the plane that contains these two lines. Okay? This is very important for this proof. Now, what does the proof actually say? It says, straight lines which are parallel to the same straight line and are not in the same plane with it are also parallel to one another. For let each of the straight lines AB and CD, okay, this is AB here, this is CD here, be parallel to EF. Okay, we've already established that these two lines are parallel to this one right here. And these two lines are not in the same plane as this one is. I say that AB is parallel to CD. So we're going to say that AB here is parallel to CD here. For let a point G be taken at random on EF. Well, we did that right there. And from it, let there be drawn GH. Well, this is GH right here. In the plane through EF, AB at right angles to EF. Now this line, this GH, is at right angles to EF. Now it doesn't look that way, but if you're looking at it from a three-dimensional point of view, remember this line extends from one plane to the other. And even though it doesn't look 90 degrees, if you were looking at it three-dimensionally, you would see it would be 90 degrees. Alright, follow along so far? And we're going to draw GK. Well, this is GK right here. And it's going to be drawn in the plane through FE and CD. Okay, so EF and CD. And this line right here is going to be at right angles to EF. In a three-dimensional sense, it actually is. But of course, you'd have to see this three-dimensionally to really understand that, or to comprehend it, which is a better word. Now, since EF is at right angles to each of the angle lines, I'm sorry, let me try that again. Now, since EF is at right angles to each of the straight lines GH and GK, okay, so EF is at right angles to this and to this, and EF is parallel to AB, okay, and this is all because of Euclid Book 11, proposition number 4. Therefore, AB is also at right angles to the plane through HG and GK, and this is by Euclid Book 11, proposition number 8. Okay? So, AB is at right angles to the plane through HG and GK. Okay? So I'm assuming that HG and GK are in a plane all by themselves, and AB is perpendicular to that particular plane. For the same reason, CD is also at right angles to the plane through HG and GK. Therefore, each of the straight lines AB, CD is at right angles to the plane through HG and GK. But if two straight lines be at right angles to the same plane, the straight lines are parallel. This is by Euclid Book 11, proposition number 6. Therefore, AB is parallel to CD. And that's the end of the proof. Alright, I will tell you more in a future video, so I'd like for you to stay tuned.